Maths Chapter 3 Understanding Quadrilaterals. Let's revise these shapes. First one is simple open curve. Second one is not a simple curve because lines are overlapping. Third is simple closed curve. And fourth is a closed curve that is not simple. Now let's learn about polygons. Polygons are closed figures formed of only line segments. Left hand side figures, you can see they are made up of line segments and no line is overlapping. Right hand side figure has overlapping lines as well as the third figure is not a closed figure. Next is classification of polygons. Polygons are classified according to the number of sides they have. 3-sided figure is called triangle, 5-sided pentagon, 8-sided octagon, and so on. Next is diagonals. Diagonal is a line segment connecting two non-consecutive vertices of a polygon. Let's see and understand in this figure. In the first figure, S and P are consecutive vertices, whereas S and Q are non-consecutive. So the line joining SQ is its diagonal. Similarly, P and R are non-consecutive, so a line joining PR is the diagonal of that figure. Next figure, non-consecutive sides of ER, B and C. So line segment joining EB and EC are the diagonals, and so on. Next is interior and exterior of a closed curve. The inside portion of a curve is called interior and outside the curve portion is called its exterior. Interior has a boundary and exterior has no boundary. Next is convex and concave polygons. In convex polygons, the diagonals lie in the interior of the polygons, whereas in concave polygons, some of the diagonals lie in the exterior of the polygons, as shown here in the figure. Next subtopic is regular and irregular polygons. A regular polygon is both equiangular and equilateral, means all its sides are equal and all its angles are also equal. For example, equilateral triangle and square, these are regular polygons. Whereas a right angle triangle, a rectangle, these are irregular polygons. Next topic is angle sum property. You can see a four-sided figure that is a quadrilateral and it is divided into two triangles. You have already learned that sum of all angles of a triangle is 180 degree. So sum of all angles of two triangles means 180 plus 180, that gives you 360 degree. Therefore, sum of all angles of a quadrilateral is always 360 degree. Same way we can find the angle sum property of other polygons too. Let's see the third figure here. It is a 5-sided pentagon and is divided into three triangles. So 180 plus 180 plus 180 for each triangle gives us a total of 540. That means if we add all the angles of a pentagon, its sum total will always be 540 degree. The next figure is a hexagon. It has 6 sides and can be divided into 4 triangles. Therefore, 4 multiplied with 180 will give the sum of all the angles of a hexagon, which is 720 degrees. That is, sum of all angles of a hexagon is 720 degrees. Point to notice is 5-sided figure is divided into 3 triangles, that is 2 less than the number of its sides. 6-sided figure is divided into 4 triangles, again 2 less than the number of its sides. So we get a general formula with which we can find the sum total of all angles of any polygon, and the formula is n minus 2 whole multiplied with 180 degree. Next is exterior angles of a polygon. Sum of exterior angles of any polygon is always 360 degree. Be it any polygon, pentagon, hexagon, decagon, any polygon, but the sum of exterior angles of that polygon will always be 360 degree. Let's try to find out the measure of all the exterior angles of the given figures here. In the first figure, The measure of x is 90 degree using linear pair. 180 minus 90 gives us 90. Similarly, z is 150 degree because its linear pair is 30. So 180 minus 30 gives us 150 degree. Also, x plus y plus z equals to 360. Sum of all exterior angles is always 360. Therefore, 90 plus 150 plus z gives us 360. So the value of z is 120 degree. Similarly, for the second polygon, using linear pair, we can find the value of x equals to 60 degree, value of y equals to 100 degree, and value of z equals to 120 degree. And because w plus x plus y plus z will give us 360 degree, we can write w plus 60 plus 100 plus 120 equals to 360 degree. And so the value of w equals to 80 degree. Let's take the example of a regular hexagon. A hexagon has 6 sides, 6 equal sides because it is a regular hexagon, 6 equal interior as well as exterior angles. So 6 equal angles, both exterior as well as interior angles. If they are equal, they'll have same measure. So let's try to find out the measure of exterior angle of a hexagon. Suppose the measure of one angle, exterior angle, is equal to x. There are 6 angles, therefore we can call it 6x. And the measure of all of these together is 360 degree because measure of all exterior angles of any polygon is always 360 degree. Now you know how to find the value of x. 360 divided by 6, which gives us 60 degree. So measure of exterior angle of a hexagon is 60 degree. Now suppose we know the measure of an exterior angle of a regular polygon. So can we find out which type of polygon it is? Let's take an example. Suppose the measure of one exterior angle is 24 degree. Now we don't know how many exterior angles are there. We don't know which figure it is, which polygon it is. So let the number of angles, exterior angles, be x. So x angles are there, each angle is 24 degree and the measure of all these angles together is 360 degree. That is the total measure of exterior angles. It is always equal to 360 degree. So we can write 24 multiplied with x equals to 360 degree. From here we can find out x. X is 360 divided by 24, which gives us 15. Means how many sides are there? 15 sides. So this polygon has 15 equal sides and this polygon is called pentadecagon or 15-sided regular polygon. So this way we can find the value of x, or we can say that we can find the number of sides of a polygon if we know the measure of an exterior angle of a regular polygon. Now let's learn about different kinds of quadrilaterals. Basically, 3 types of quadrilaterals is what we are going to learn. First one is trapezium, second is kite, and third one is parallelogram. And in parallelogram, we are going to learn about 3 different types of parallelograms: rhombus, rectangle, and square. These are special type of parallelograms. So let's see one by one the property of each of these figures. First type of quadrilateral is trapezium. Trapezium has only one pair of opposite sides parallel to each other. The figures that you see on the left hand side are all trapeziums. On the right hand side, the figures which are shown here are not trapeziums. So either the top side is parallel to bottom side or the left side is parallel to right side. But these parallel sides are not equal to each other. The next quadrilateral is a kite. Its property is that its two distinct consecutive pairs are equal to each other. Also, its diagonals are perpendicular to each other. See the first figure. AB is equal to AD and BC is equal to CD. The right hand side figures are not kites because either the opposite sides are equal or three sides are equal to each other. Now let's learn about the properties of a parallelogram. Here you can see ABCD is a parallelogram. AB and CD are opposite sides. Similarly, AD and BC are opposite sides. Angle A is opposite to angle C. Angle D and angle B are opposites. Its name is a parallelogram because it is made up of two sets of parallel lines. So AB is parallel to CD. AD is parallel to BC. So the first property is opposite sides are parallel. And because both sets of lines are parallel, they become equal. Opposite lines are or opposite sides are equal to each other. So AB is equal to CD and AD is equal to BC. The third property is about the angles. Opposite angles, angle D and angle B are opposite angles and they are equal. Fourth property is again about the angles. Adjacent or consecutive angles are the neighboring angles, like angle A and angle D. They are neighbors or consecutive or adjacent angles, and when we add these two angles, their sum is always 180 degree. Means they are supplementary. So adjacent angles are supplementary. So the sum of these two angles, that is adjacent or consecutive angles, their sum is 180. Means these angles are supplementary. And the fifth property is the property of diagonals. AC and BD, these blue lines that you can see here, they bisect each other. They intersect each other at O and they are cutting each other in halves. That is, AO and OC are two equal parts of AC. Similarly, DO and OB are two equal parts. OB is equal to OD, AO is equal to OC. That is called bisecting. So the diagonals of a parallelogram bisect each other. Now let's learn about special type of parallelograms. The first one is a rhombus. This is a rhombus. A rhombus has all four sides equal. Because it is a parallelogram, it has all the properties of a parallelogram. So the first thing is, has all the properties of parallelogram. It is a special type. Its special property is all its sides are equal. And the second special property of it is its diagonals. These two diagonals which you can see, they make an angle of 90 degree with each other as they bisect each other. They bisect because diagonals of a parallelogram bisect. It is a parallelogram, so its diagonals also bisect each other, but they make an angle of 90 degree with each other. So all four angles which you see here are 90 degree. So the two special properties are all sides are equal and the diagonals bisect each other at 90 degree. These are the properties of a rhombus, and rest of the properties are same as that of a parallelogram. Now let's see another special type of parallelogram, which is a rectangle. You have already learnt about a rectangle. Its opposite sides are equal. It is also a parallelogram, so it has all the properties of a parallelogram. Other than the properties of parallelogram, it has some special properties. The first one is all angles are equal. These are the angles, and you know, in a rectangle all these four angles are equal and each one of them measure 90 degrees. Another special property is that of a diagonal. These are the diagonals of a rectangle. The special property about the diagonals of a rectangle is that these diagonals, they are equal in measure. That is, the length of AC and the length of BD both are same. So diagonals are equal in length, and this is only for the next special type of parallelogram is a square. Now this square is a very special figure. You already know about a square. It has all its sides equal, all its angles are also equal. It is also a special type of rhombus, and it is also a special type of rectangle. So because it is a parallelogram, it has all the properties of a parallelogram. Because it is a special type of rhombus, it has all the properties of a rhombus. And because it is a special type of rectangle, it has all the properties of a rectangle. Means all its sides are equal, opposite sides are parallel, all angles are equal, diagonals are equal, diagonals bisect each other, and they bisect each other at 90 degree. These all angles which are equal, they are also 90 degree. So square is a very special type of figure which has the properties of a parallelogram, a rhombus, and a rectangle.